University of California, Irvine, and today I'm going to be talking about evaluating and testing NLP models. So let's get started. So suppose you want to know whether a model, an NLP model, really work or not. Right? So suppose you're a researcher and you're working on NLP models, and a new paper comes out. Let's say it's called Oscar, that produces like an amazing results on a bunch of benchmarks. The question that you may have is whether you should replace whatever you're working with Oscar-based model, right? And this could happen in pretty much any field ever. But if you think about companies in industry, you have Google, Microsoft, Amazon. They really want to also ask similar questions, like should we now replace whatever we're using right now with Oscar? Should we change our products to now adopt Oscar? Right? And so the question is, how do you make such a decision? One sort of naive answer could be to let's look at leaderboards. This is something that we've been using for a long time. Let's see where Oscar is on the leaderboards. Right? And if you look at what the leaderboards were, so this is a squad leaderboard initially, where human performance was beaten by machine learning models quite a while ago. Even Squad 2.0, which was introduced, there were models that were introduced that were beating humans on that as well. Right? And so this is just a single task. Maybe you can look at leaderboards that cover a bunch of different tasks. So this is Glue leaderboard that covers a bunch of sentiment, NLI, paraphrases, all of these kind of things. And you can see, okay, where does Oscar fall on this leaderboard? And you can see already, even before Oscar, a bunch of methods are really, really good. In fact, humans are at number 9 down there. Right? So clearly, these leaderboards, machine learning has outperformed human on these leaderboards. And therefore, we can maybe confidently say, yay, we've solved NLP, and any model that does better now can be adopted. Right? But unfortunately, we know this is not the case. We wouldn't be having this workshop today if that was. And part of it is because there are lots of known problems with using accuracy or using leaderboards. They kind of go hand in hand in order to evaluate models. The main issue that we are all familiar with is that leaderboards or accuracy sort of duplicates the biases of data collection. So if there are shortcuts somehow in your training data, if the test data is also collected the same way, and it often is, the same shortcuts show up. And so the model is able to use those shortcuts to do better. And so this kind of does not represent real world usage, right? So the Microsoft product that's deployed onto Twitter is not going to see the same test distribution that it was evaluated on. But this is just one of the problems. I think there are some of the other problems that don't get as much attention, but are also pretty important. One of the problems is that most of these leaderboards come with a single metric or a single number. And that number on an absolute scale is somewhat meaningless, right? Like 80% on sentiment, what does that mean? On an easy data set, that's like really bad. On a difficult data set, that might be really good. So this number and what it means is not very useful. And in fact, we do not even, these numbers also don't provide a breakdown of what the model capabilities are, right? So what is the model good at? What is the model bad at? How can we fix what's wrong with the model? Just giving an 80% number is not very useful for that. And so this goes back to the same question, which we would have thought is a really important question to have answered by now, which is to like, how should I replace my model, or whether I should replace my model or not, or should we use this new model or not? And this problem, I would claim, is not really being solved so far yet. So what we are trying to do is sort of take first initial steps in sort of providing useful tools and ways of framing questions that hopefully will be helpful in evaluation. Specifically, we are thinking of what are the possible bugs that might show up in NLP, and provide tools to help you try and find those bugs. Right? And in the talk, you will see some of these methods are automatic in the sense that you just throw your model in and it'll automatically show you what the problems are. But increasingly so, we've been thinking about using the expertise that you have about the domain as part of the process for evaluating. All right, so the main core contribution that I'm going to focus on in this work is this idea of perturbation-based testing or behavioral testing. The idea is you have some instances in your data, let's say validation data, sometimes might even be unlabeled data, but we won't worry about that too much right now. And so you have these XY pairs. This could be anything that you're doing. You write some transformation functions, which would be automated or manual, that give you a perturbed x called x prime and an expected output associated with that perturbed x. This is what you expect, ideally, a model would do. And then the idea to test is to take those x prime, y prime, prime pairs, give it to a model. You're not looking at the internals of the model, nothing like that. You give it to the model and ask it what it thinks the output should be. Maybe it says y hat. Just look at whether y hat and your expected output match or not. And if they match, then you pass the test. And if they don't, then you haven't. And this idea of perturbation-based testing, we've been sort of exploring and looking at very different parts of this. And we have a string of papers on using transformation functions that are somewhat automated, that work across multiple tasks automatically, but also some methods that are much more manual, where you have to sit down and sort of think about almost at a per instance level, sort of what's going on and write some transformation functions. And then I want to mostly focus on this recent work on checklist, where we sort of create a testing framework that allows you to deal with multiple kinds of transformations. So let's get started. I'm going to give you a few examples from the work and then focus mostly on checklist. So first, I'm going to talk about SEARS, which is semantically equivalent adversarial rules. That's a lot of tech-sounding words, but the main idea here was to say that I'm going to take my original X and I'm going to transform it without changing its meaning. Right? So in some sense, it's going to be paraphrasical edits, or I don't know what you want to call it, but the meaning is exactly the same. That's why it's semantically equivalent. And clearly, in that case, we don't expect the output to change. So there is no y prime, there is just y. And then we send x prime to the model and see whether the output has changed or not. So I'm not going to go into the details of how we do it, but here's an example that we found for question answering system. This was a visual question answering system. So you have an image here with the stop sign. And the question the user has is, what type of road sign is shown? And the model is actually pretty good on this task. It says it's a stop sign, which could be pretty useful in a very practical setting if you don't know what that road sign means. But interestingly, if the user says, instead of what type of road sign is shown, if they say which type of road sign is shown, which does not change the meaning in any way, somehow the output of the model changes. It becomes do not enter. Right? Now, this kind of adversarial attack is very different from the ones you see with images and pandas and things like that. This is what I would call a bug, because it's very likely in the real world. Right? I'm not even sure which of these phrasings is better. Maybe one of them is slightly better than the other, but both of them are pretty likely in the real world, and models should be robust to this. And these paraphrasical sort of transformations are one way to get at that. We sort of extended this work to go beyond just single instances to see what happens. And what we did was we tried to find rules that seem to generalize across multiple instances. So instead of just looking at what has changed for this instance, we looked at what happens when you change every occurrence of what type with which type, or maybe even more generally, every occurrence of what noun to which noun. And we know that this change is not going to change the meaning of the question. Does it change the meaning of the output? And in this case, it did. And so you can come up with a rule that says, hey, in your model, every time you replace what noun with which noun, there's a high probability that it flips the output. So this might be a bug that you might want to do something about. The second example I'll give is one called triggers, where the idea is to find transformations where we're just adding a short snippet of text. So what we're trying to do is concatenate an irrelevant phrase, and we're hoping that it shouldn't change the output. It's completely irrelevant. Again, I'm going to give an example here. And just a warning, this was sort of pushing how bad the models could get. So this example might offend some people. So what we wanted to do was look at question answering. So these are two instances where you have the question and some context. And the question is, why did he walk? The answer is exercise. The second one, the question is, why did the university see a drop in applicants? The answer was crime and poverty. What you can do is you can add a phrase, why, how, because, to kill American people. It's fairly nonsensical phrase, is somewhat irrelevant to the context. But turns out that for some reason, this is really important. And it changes the answer to say to kill American people. What is even more interesting is you can use that same irrelevant phrase on a different paragraph. And again, the answer changes to kill American people. Right? So somehow this "to kill American people" is becoming the answer because the model is getting triggered by the rest of the phrase. And so, in fact, 1/3 of the answers, when you throw it in, became "to kill American people." And that's a problem. That's, I would say, a security bug in your model. Okay. One last example I'll talk about before I talk about checklists is this idea of implications, where in this case, this is an interesting example where we were doing the transformation, but we were doing it for question answering. And we were changing the question such that a specific answer is implied. So in this case, in fact, we were changing y to be a different y prime as well as changing the question. I think this is most easy to understand with an example. So suppose you're doing VQA and you have an original question like how many birds are there within an image, and the answer is 1. What you can do is you can say, okay, I'm going to look at this question and answer pair, and I'm going to create a bunch of more question and answer pairs that are clearly implied by this one. So for example, we're going to say, is there 1 bird? If I ask you this question and I told you that the first answer is correct, you would say, well, clearly the answer here is yes. If I ask you, are there 2 birds? You'll be like, well, you said 1 to how many birds are there? So clearly there can't be 2 birds. And if I say, are there any birds at all? You will say clearly, yes, there are some birds, right? So these are all question answer pairs that are logically implied by the original one. And so if a model gets the first one correct and it's logically consistent with itself, it should get all of these correct. Maybe not too much of a surprise. Well, actually, what is interesting is that all of these pairs can be created without actually looking at the image. It's conditioned on the fact that you got the first answer correct. Turns out most of the models are really good at getting the first question correct, but they're really, really bad at getting the rest of them correct. And we show statistics in the paper that how bad the models can get. Sometimes they're no better than random in answering these. So we wrote this sort of manual transformation function that looked at these specific phrasing and got a way to generate these automatically. But we were able to generate these for 2/3 or 3/4 of the validation data of VQA and SQuAD. So it becomes a useful evaluation data to have just to evaluate your model. Okay, so with that, I want to start talking about checklists in the remaining time, which is our unified testing framework for NLP models. So where we started was this obvious observation at this point that there are lots and lots of known issues in NLP models. You have adversarial examples, shortcuts and biases, lack of consistency, not being robust to typos, and then fairness and a bunch of these sort of issues. And people have studied each of these issues for each sort of task that's common, right? So adversarial examples for sentiment analysis, robustness for typos for machine translation, shortcuts and biases for question answer. Like all of these sort of different combinations have been tried. And that's great. This is very useful to the community. But when you come to someone who's a practitioner for their own model and for their own task, it's not clear how relevant this work is. In fact, does it help them evaluate their own system better by knowing all of these different combinations exist? And so this was the question we were struggling with, like, hey, how do you evaluate your own model on a specific task? And, this is sort of flippant, but if only we had experience testing complex systems. And then if you ask that question, the answer is, well, a lot of us are software engineers and we are trained in software engineering. And so the answer is kind of obvious. We have testing. We have this decades of practices for software testing. Can we take some of those lessons and apply them to NLP? So that's sort of what checklist is doing. It's taking some of the ideas that we are familiar with. I'm sure there are many that we are not. And how do we apply them to NLP? So I'm just going to sort of walk through what that might look like. So the basic principle of software engineering testing is to write and test small units, right? Like break your problem down into individual features or functionalities and test them. For us, we don't want to break down layers and modules and things like that. We think of them as linguistic capabilities, right? What are sort of the capabilities you expect your model to have if it is doing a certain task? So for example, you might want to look at what does the vocabulary look like? Like, does it understand some words? Does it not understand some words? What do the named entities look like for this? Like, is it able to handle named entities? Is it able to handle negation? And you can name a bunch of these things, and you can talk to a linguistics person to sort of help you with this if you need. Right? But apart from that, the other important thing is, okay, this is what we want to test. How do we actually test it? Well, there is this idea of behavioral testing in software engineering, where you want to decouple the test from the implementation. So you don't want to test the internals of the implementation. You want to test how it behaves. In NLP, this is somewhat easier to do. What we want to do is we are not going to worry about the training process, the training pipeline, the loss function, none of that stuff. You're giving me a model that is supposed to solve this task. I'm just going to test that as a black box. And how am I going to test it? I'm going to test it with different kinds of tests that I'm going to write. And so what we're going to do is we're going to take all of these capabilities that we want to test, and we're basically going to put it in a matrix, and we're going to have a bunch of different test types, 3 so far, that we can use to test each of these capabilities. And I'll quickly walk through what those look like. So the first type of test is maybe the simplest one to understand, which is just writing unit tests. Right? You have some known inputs, and you just want to make sure the output matches those inputs. For us, we call it minimum functionality test. It sounds a little bit more precise as to what it's doing, which is testing one minimum aspect of functionality. So let's look at an example, and this is the first example of checklist. And we're going to be doing this on sentiment analysis, right? And we're going to be looking at vocabulary capabilities of sentiment analysis. What does that mean? What we can do is we can write really simple, short statements, like this was a great flight. The model should know this is positive. I hate this airline. The model should know this is negative. This might look a little bit like your test set, but we are saying, okay, let's ignore the test set. I'm just going to focus on sanity checks that the model should clearly work on. And we tested a commercial sentiment analysis system, and it gets some of them wrong. And we created lots of these test cases, and we got about 7% failure rate. Is that too high, too low? That's kind of up to you, but now you know what that failure rate is. We can take another example of sort of words that we think are neutral by writing a bunch of factual statements. This is a commercial flight. That was an English cabin crew, right? And lots of examples of this. We expect all of them to be neutral. And turns out sort of commercial systems are maybe not as good at this. They get about 11%. And I'm talking about the Google system here. Okay, so that was our first type of test. We can write, let's also look at negation actually before we go on. For negation, we can again write very simple statements. The cabin crew was not good. The pilot wasn't nice. The flight wasn't great. We expect all of them to be negative because we've taken a positive sentiment and negated it. And on this one, actually, the failure rate was quite high. It was almost 50%, which means suddenly we now know that these systems are not very good at negation. Okay. A different type of test that we have is called, I guess, metamorphic tests, which work with unknown outputs, but they work with existing data. So we call them invariance tests when we take them to NLP because it's a little bit, it makes more sense when we think about what the output should be. And the idea here is we're going to do perturbations to the input where we don't expect the output to change. So this becomes a different column. So now we suddenly actually have a matrix since we have multiple columns now. And this kind of test can be used to test any of the capabilities that are listed. So here's an example for what invariance test for named entities looks like. So what we do is we take existing tweets or existing data that exists, and we find named entities in them and replace them with a different named entity. And clearly, we're just changing named entities. We should not change the sentiment based on this. So Chicago goes to Dallas, so Brazil goes to Turkey, and so on. And we expect that the output should not change. Do the models pass this test or not? Well, if you're changing locations, they fail 20% of the time. Just to be clear, all of these failure rates should be 0 as far as I'm concerned. Okay. We have another version of these perturbation tests, which we call directional expectation tests, where we again change the input, but we expect the output to change a certain way. This is again easy to see with an example. So what we're going to do is we're going to look at the vocabulary tests, the vocabulary capability again, and see what directional tests look like for that. So here's an example. The American Air service wasn't great. You are lame. We are adding "you are lame" phrase to these tweets. And all we are claiming is that you shouldn't become more positive about these tweets. Here's another example. Whatever tweet says, "I dread you." That shouldn't make the sentiment more positive. We expect the sentiment, at least not to go up. And then the model actually fails again about 50% of the time. So these are some of the tests that you can write for sentiment analysis. And there are a lot more in the paper. I encourage you to sort of look at that. Okay, so what we are actually proposing here is this checklist paradigm and toolkit to help you generate tests. The first step you should do if you want to do checklist is to define what are the capabilities needed for your task. If you're doing sentiment analysis, what are the different capabilities you wanted to have? What are the behaviors you expect a sentiment analysis system to have? The second thing to do is sit down, spend a few minutes with each capability, and write down test cases for each capability. Right? How are the different ways that you would want to test the behavior? And try to use labeled data, unlabeled data, and some of the tools we have to generate as much of a comprehensive set of test cases as you can. And finally, just run any model that you think you want to evaluate through these tests, and you'll get a report card with how your model is doing on different capabilities for different tests. Okay. One last thing I want to talk about for checklist is how the tooling works and sort of what it provides. Essentially, it provides some abstractions to make the tests more comprehensive. Essentially, we work with template-based test cases in order to increase coverage of your tests. So instead of saying this is a good book as the test case, we will encourage the users to write this is a positive thing, where positive and thing have a bunch of substitutions that you can describe. Along with this, and then we just generate all possible combinations. We also help you expand these templates if you don't want to list what all the positive and things are that you care about. You can use Bert or Roberta as suggestions for what to fill in. Here's an example. You can sort of get possible fill-ins, pick ones, and remove them. You can also use existing lexicons that we provide in order to apply your template. So for example, we have lexicons for names, countries, blah, 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 and you can use them to write templates. We also have these lexicons that we can automatically expand using BERT in conjunction with WordNet. So for example, if you say this is a bad book, we can find antonyms from BERT, from WordNets, like good, unregretful, unregretting, and things like that. And then we filter them out using BERT to only give you the ones that might be useful. Okay, there are a couple of other things that we provide, like simple perturbation functions that you might find useful in your specific use case. Right? Okay, all right. So instead of going through the sentiment analysis example, I think I'm gonna end my talk now with briefly talking about one case study we did with Microsoft's sort of sentiment analysis team. So this is the team in charge for their commercial product. And this model is already well tested. It uses public benchmarks and all kinds of things to test itself. They spent about 5 hours with checklist, and they came back with sort of many different bugs that they didn't know about. They thought checklist was useful to test new capabilities that they hadn't thought of, but it also tested their old capabilities, the one that they knew they were testing already. With using checklist, they thought they tested it better. So in summary, you should be testing your models, right? I talked about behavioral testing, how you can perturb and test for specific phenomena. And I talked about some automatic ways of doing this, like just do paraphrases and you get some interesting behavior. Try to append some words and see that can change things or not. But you can also do some manually defined perturbations that might be specific to your task, but still might show you some specific kind of bug that automated methods won't help you with. And then I talked about checklist, which provides a framework to sort of unify all of this in order to help you test better. And I just want to stress this again, like if you don't take anything else from the talk, at least this takeaway is really important. You should make testing part of your pipeline. Since we published this paper, we have talked to a bunch of different teams in a few different companies and tried to apply it to a bunch of different tasks as well, like machine translation, language models, NLI, and so on. And there is this consistent behavior we've seen where everybody sort of starts with skepticism, like this is not like, we've been testing our system for a long time, why will this work better? And then when they actually apply checklist, it leads to a surprising result, like, hey, I didn't know this was a problem. And based on this, they end up adopting checklists into the pipeline. So we can't always convince you to do this one-on-one. So hopefully this talk is helpful, at least to think about testing, if not using checklist. That's all I have. Thank you. If you have any questions, I will be happy to take them right now or day after tomorrow. And if I don't get to your questions, feel free to get in touch. Thank you.
Thank you very much. That was a really great talk, and it's already stimulating some discussion on the chat. There were a couple of common questions since we have a lot of speakers and people interested in dialogue. And so one of the questions was, what do the behavioral test cases look like for something like a conversational agent?
Yeah, that's a good question, and that's something that we haven't directly looked at yet. We've been looking at other generation kind of things like language modeling and machine translation. Dialogue is definitely one that we want to look at next. I think there are sort of some specific cases you can create where you can create simple dialogues where you know this is what's going to happen, and therefore like a simple dialogue, like if a user says this, clearly I should know how to react. And some simple templates using that. You can probably create thousands of examples. But yeah, more generally, and how to take multiple turns into account is something that we're looking at and don't have a good answer for yet. Yeah.
Great. There was a question earlier about whether you have, some of these resources seem to be dependent on English language resources, and you have some comparable materials for other languages than English.
Yeah, that's a good question, and that's a really important question as well. We've been thinking a lot about this. We have been working on, and Marco, who's the lead person on this, has been working on support for multiple languages. And the main thing, I think there's nothing in the idea that's specific to the language. You know, it's something we tried in English because that's what was a common language amongst the authors. But the main problem for porting into different languages that we rely on masked language modeling like BERT and Roberta and things like that to sort of extend the vocabulary. So you fill in a template, but you only partially fill it in, and we use masked language modeling to expand that quite a bit. And so we've been sort of using multilingual BERT and things like that. Their quality is not quite as good as English, and similar with other resources we use like WordNet. Some of the quality deteriorates when you go to different languages, but I think when it works, the ideas just directly translate over. So you can check out the repository, and there are probably some notebooks about this stuff as well.
Great, thank you very much. And yes, there was somebody who chimed in about Euro WordNet as an option for multilingual work. So. Yeah, I'd like to again thank all of our speakers for the session, for great and engaging talks. As we wrap up this session, the next session is the poster session and lunch. So please do hop over to the posters and sponsors section, and you can talk to people individually or in groups. And I hope you all find that really enjoyable. And again, thanks very much to all the speakers. Hopefully they will have a few minutes to follow up with any of the remaining questions in the chat.
Thank you.